this is Ashley.
And for this food video, we're going to do the chemistry of food coloring.
Hope you enjoy it. Food coloring, by definition, is digestible color additive of any dye, pigment, or substance that imparts color when it is added to food or drinks.
Some examples of food colorings we use are blue dye number 1. This is often found in bottled food colorings, such as icings, ice pops, blue raspberry flavored products, sweets, and drinks. Another one is green number 3. This is used for tinned green peas and other vegetables, jellies, sauces, fish, desserts. Another one is red dye number 4. This is very popular as a food dye across the world. Lastly, yellow dye number 5 is the most popular dye to be found in foods. This is often found in ice cream, hard candy, gelatin, soft drinks like Mountain Dew, energy and sports drinks, Doritos, jelly, cereal, and many more.
A food dye will appear a particular color because it absorbs light whose color is complementary to the food dye's color. So, for example, blue dye is formed when incident white light is shined and red, orange, and yellow is absorbed, which creates the transmitted light of green, blue, and violet. This forms the color blue. Red dye is formed when incident white light is shined and green, blue, violet is absorbed, which creates the transmitted light of red, orange, and yellow. This forms the color red. That being said, for the color green, the colors absorbed would be orange, red, and violet, and the transmitted light would create green, yellow, and blue. In the color violet, it is formed by the absorption of orange, yellow, and green, which transmits into violet, red, and blue.
For this experiment, we did food coloring, milk, and soap.
When the cotton swab with the dish soap touches the milk, it floats on top and spreads over the surface, and the food coloring quickly moves away from the cotton swab. This happens because soap is mostly a surfactant, which means it has a hydrophilic part that wants to interact with the water and a hydrophobic part that doesn't want to interact with the water, but just wants to love the fat molecules. As the soap spreads, it decreases the milk's surface tension, and as the soap spreads from the cotton swab, the higher surface tension surrounding this area pulls the milk along with the food coloring towards it. And since soap is a degreaser, the molecules attack the fat in the milk, dissolving it, which causes a swirling motion of colors. Instead of artificial food coloring that you buy in the store, you can buy natural food coloring that comes straight from the food you're eating. One of many natural food colorings are carotenoids. Those are the deep red, yellow, and orange colors. But don't eat too many foods that contain beta-carotene. Your skin may turn orange, but don't worry, it's harmless.
Chlorophyll is another natural pigment found in all green plants. It absorbs sunlight and uses its energy to synthesize carbohydrates from carbon dioxide and water, known as photosynthesis.
Anthocyanin is the best natural source for deep purple and blue colors. It can be found in grapes, blueberries, and cranberries. The chemical compound which is shown here is soluble, meaning it can be dissolved in water. So it is used to color water-based products such as blue corn chips, brightly colored soft drinks, and jelly.
Turmeric is a deep yellow color. It's the color that's added to mustard to give that deep, bright yellow.
For this experiment, we did water, oil, and food coloring.
The water-based drop remains intact until it sinks through the oil and contacts the water, at which point the water at last disperses. The oil remains separated from the water because it lacks polarity and floats because it's less dense. The one that weighs more is more dense. To tell how dense it is, put it in water. If it sinks, it's denser. If it floats, it's less dense. Molecules of water can't mix with the molecule of oil, even if you try to shake it up. Food coloring only mixes with water, and it does not color the oil at all.
Here are some fun facts about food coloring. Did you know if you're eating food that's red in color, you could be eating bugs? It was actually purposely added by the food manufacturer. The bug is known as a cochineal, which is this insect right here. There's actually this red extract in the insect that is used to color certain foods. It sounds gross, but people have been using it for years. Even the Aztecs have used these insects. but theirs was mostly for dyeing fabrics a deep red color. But don't worry, it's safe to ingest. I mean, it's just a bug.
Food coloring can be dangerous. It has been linked to cancer, hyperactivity, asthma, and allergies. Food dyes are added to our foods and drinks to make them more fun and appealing to our eyes and taste buds.
I hope you enjoyed our video on the chemistry of food coloring.
And stay tuned for our next experiment on more food chemistry.